So hi friends, in this lecture let's discuss a problem. So based on Darcy Weisbach equation. So this Darcy Weisbach equation has been derived in the previous lecture. Hope you would have seen that and we have got some idea. So we'll see a simple problem how to find the head loss due to friction in a pipe flow. So an oil of a specific gravity 0.7 is flowing through a pipe of diameter 300 mm at a rate of 500 liters per second. Find the head loss due to friction and power required to maintain the flow for a length of 1000 meters. Take mu, which is equal to 0.29 Stokes. It's a kinematic viscosity is given. So oil which flows in a pipe. So the pipe diameter is 300 mm. So you're going to convert in terms of meters. As I said, you have to convert everything into meters and power in terms of newtons, right? The rate of rate of flow, which is called as a discharge, it is 500 liters per second. So you need to convert them into meter cube per second. So 1 meter cube will be 1000 liters. So divide by 1000, so 0.5 meter cube per second. We need to find the head loss due to friction and power required to maintain the flow. So due to this friction there will be some loss in energy, but we need what is the actual power that is required to maintain this flow. So we need to know once we found the head loss due to friction. So to overcome this frictional loss, what will be the power required to maintain the flow for the length of 1000 meters. So 1000 will be length of the pipe. So to find the head loss due to friction, so we know the formula will be 4F LV square by 2GD. So F is a frictional factor, so or coefficient of friction. So it is not given, we need to find. L is the length of a pipe, is given 1000 meter. V, we need to find the velocity. T is diameter of pipe, is given 0.3 meter, and G is acceleration due to gravity, is 9.81. To find F and V, so first we're going to find the velocity. You know this discharge, so discharge will be equal to area into velocity. So if to find the velocity, then velocity will be equal to discharge by area. So discharge is given 0.5 meter cube per second divided by area pi by 4 d square. So d is known 0.3 meter. So we substitute and we can get 7.073 meter per second will be the velocity of a fluid flows in a pipe. To find the frictional coefficient of friction, so we need to know the Reynolds number. To find the Reynolds number, so the formula will be rho Vd by mu. So its mu is a dynamic viscosity. So we know that for kinematic viscosity will be mu by rho. So instead of directly substituting mu, so we can directly substitute mu. So we can take the rho out. So Vd by mu. So this simplification we have seen in dynamic and kinematic viscosities in unit number 1. So V will be equal to 7.073 into d is the diameter, mu is given 0.29. So it's given in terms of Stokes, so we need to convert in terms of meter per second, second square. Sorry, meter square per second. So if you convert, it will be 0.29 into 10 power 4, so which is equal to, so simplifying will get 7.316 into 10 power 4, so which is greater than 10 power 4. So we're going to use the formula. So we have two formulas to find the frictional coefficient based upon the Reynolds number, which is if it's less than 2000 we have another formula, if it's greater than 4000 we have 4000 we have this formula. So 0.79 divided by Re power 1 by 4. So Re value, so this Re value, so if we substitute, then we will get the frictional factor or coefficient of friction, which is 0.0048. So it's an unitless parameter because the Reynolds number is a unitless parameter. So if we substitute the units of all these parameters, it will be nullified, so it doesn't have a unit. So head loss due to friction will be, we have found V and F, so substituting all these parameter values of the parameters, we will get 163.18 meter, which will be the total head loss. So due to this frictional loss, this will be the loss of energy or head in terms of meters. So power required, so to maintain the flow, so power required will be weight of the fluid. So what is the actual weight of the fluid? into what is a discharge per second. So what is the flow rate, okay, into head loss to friction divided by 1000, because this formula will be in terms of kilowatts, so I mean watts, so by 1000 into kilowatts. So rho g is a weight, so weight into discharge per second க்கு எவ்வளவு fluid discharge ஆகும், and what is the loss. So if you are able to get this value, that will be actual power required. So rho is the density of liquid, so it is given as 0.7 is a specific gravity. So we know that specific gravity will be equal to density of a liquid by density of a standard liquid. To find the density of liquid, so specific gravity into density of standard liquid, which will be 1000. So that's why 0.7 into 1000, which will be equal to 700 kilogram per meter cube. So if we substitute these values, so rho 700, G 9.81, Q 0.5, HF we have found out by 1000, we'll get 560.28 kilowatt is the power required to maintain the flow at this velocity for a length of 1000 meter. So hope you have got some idea about the frictional loss, so how to overcome this with the additional power. Okay, so thank you guys.